Today we're going to start looking at standing waves, sound waves. But before we do that, let's just do a quick review of what we've already seen with standing waves in our spring. So we did a spring lab, and we had a spring, I'm just going to draw that as a straight line. And then we went ahead and we put some different numbers of loops in there. So we put in one loop, and then the next time, same spring, we put in 2 loops. And then the next time we put in 3 loops. And something you should recognize with all of these is that at each end, we had a node, no matter how many loops we put in. And this is because each end was fixed. So this was a fixed end, meaning the rope couldn't go up and down. And this might have been your wrist. And this was a fixed end. Maybe this was whoever was the wall in the lab, or maybe we had it bolted down at the end of a table. So in each of these cases, we're able to put in a complete loop, maybe not a complete wavelength, but a complete loop, and there was always a node at each end. But what if instead of having a wall at the other end from the person who was generating, what if we had a free end? So for instance, what if we had the spring with a loop attached to a pole that was able to go up and down? In that case, we wouldn't have gotten a node at the other end. It's impossible to get a node there. So in order to set up a standing wave, we would have had to have had an antinode. So in that case, our spring would have looked more like this. Here's our straight spring. And our first standing wave would have looked like this, where we had a node at one end and an antinode at another. Well, what would our next standing wave pattern look like? We'd still have to have a node at the first end. We'd have to have an antinode at the second end, and it would look like this for our next pattern. So in our standing wave lab, when we looked at wavelength, we said this was 1/2 of a wavelength, this was 1 wavelength, and this was 3/2 of a wavelength. Well, we don't see that in our fixed free standing waves. Right here, we don't have a 1/2 a wavelength. That would be considered 1/4 of a wavelength. So that's a little different than what we've seen before. So here we have 1/4 of a wavelength. So I can see that from a node to an antinode is always 1/4 of a wavelength. So for instance, here on the standing wave that we put in our spring, from our node to an antinode, that would have been 1/4 of a wavelength, and then from the antinode to back to the other node would have been another 1/4 of a wavelength. That's where we get the 1/2 wavelength. So if I go ahead and I label all of the nodes and the antinodes in a wave, it makes it easy to count, well, how many wavelengths do I have? So for instance, for this wave, second pattern right here, I've got 1/4, 2/4, 3/4, 4/4. That's how I know I've got 1 full wavelength. 4/4 is just 1. And in this pattern, I've got 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. Well, that's 1.5 wavelengths. I can do the same thing on the other side, and I could say, well, from a node to an antinode, that's 1/4 wavelength. So then here, for this one, if I go ahead and label the nodes and the antinodes, I can see that I've got 1/4, 2/4, 3/4 of a wavelength. So here, I've got 3/4 wavelength. All right, so now let's go ahead and see if we can solidify this and take a little bit of notes. So let's remember that nodes and antinodes for sound waves, well, they're going to be very similar to the nodes and antinodes that we see in the spring wave. So for a fixed end, we're going to see a node, and for a free end, we're going to see an antinode. So if we're putting sound wave into a tube, which we often do, so most musical instruments that are wind instruments are just tubes, different shapes of tubes. So if we put a sound wave into that tube, the closed end of the tube is going to be a fixed end, and we're going to end up with a node there. The open end of the tube is going to be a free end because the air can come out, and we're going to get an antinode there. If we don't get a node at the fixed end and an antinode at the free end, we're not setting up a standing wave, and then we won't get a loud sound. So when we set up a standing wave, and we can just put that over there. So a standing wave in a tube will result in a loud sound. And we'll see that in the lab that we'll do in class. So how do we draw these? Okay, so just like we did in our last page, I'm going to go ahead, here's my closed end and my open end. I'm going to go ahead and draw the undisturbed medium, and I always draw that as a dashed line. And then I'm going to go ahead, I'll go ahead and pick a different color here, sure, why not green. And then I know at the closed end, I'm going to have at closed end, I'm going to have a fixed end, so I have a node. And at the open end, it's going to be a free end, so I'm going to go and put that antinode. And then I'm going to draw that, and it's just a very long connection there. And I can see, since that's from one node to the next antinode, that that's 1/4 of a wavelength. That's just a count. It doesn't tell me how long the wavelength is. I have no idea how long the wavelength is right now. But I do know that the tube is 1 meter long. So from the closed end all the way to the open end is 1 meter. Well, from the closed end to the open end, I counted 1/4 of a wavelength. So I can set those two equal to each other. So I can say 1/4 of a wavelength is equal to 1 meter. Then algebra, I can solve for that lambda just like I would have solved for x in my math class. I can go ahead and solve for lambda and say, well, that means lambda must be 4 meters. So now I know the length of that wave. Well, that wave, only 1/4 of it fit into the tube, but it still set up a standing wave. So that's how we're going to do those problems. I can see that for this first pattern, right, so I would say that this is the first pattern. I can see that the first pattern has one node and one antinode. Now let's take a look at the second pattern. And let's go ahead. I didn't dash that quite well. I will fix it a little bit there. That's better. So the second pattern, I still have to have a node at the closed end, and I still have to have an antinode at the free end. I'm going to put it on the other side of the tube because I know how I'm going to draw it. But for the second pattern, I should get more of the wave in there. So I'm going to go ahead. I'm going to have to get to another antinode and then to that antinode. That's the second pattern. So if I label my nodes and my antinodes, I can see that now for my second pattern, I have 2 nodes and 2 antinodes. So this is the second pattern. You can see I have 2 nodes and 2 antinodes. And if I count, I've got 1/4 lambda, 2/4 lambda, 3/4 lambda. So I can go ahead and put, well, this is 3/4 of a wavelength. Well, the tube didn't change length, didn't change its size, so 3/4 lambda still equals 1 meter because I know the tube is 1 meter long. So now I can find that lambda is 4/3 of a meter, 1.33 meters. So I can see that the wavelength actually decreased in size to the second pattern, which is not surprising. And then if we want to draw the third pattern, I can go ahead and put my undisturbed medium line in there. Obviously, I still have to start with a node on the left with the fixed end or the closed end and an antinode on the right. And this time I've got to add in more of the wave, so I've got to get to an antinode and then another antinode and then this last antinode. And I can go ahead and label or mark the locations of all the nodes and antinodes. And I can see that now I've got 1, 2, 3 nodes. So the third pattern has 3 nodes and 1, 2, 3 antinodes. And if I count my wavelengths, I've got 1/4, 2/4, 3/4, 4/4, 5/4 of a wavelength here. So now I've got 5/4 of a wavelength. The tube is still 1 meter long. So lambda in this case has to be 4/5 of a meter, which is just 0.8 meters. So those are all the wavelengths that we're going to draw for right now, but hopefully you see a pattern at this point. Hopefully you see that when we have a closed open tube or a fixed free end, we start with 1/4 lambda. The next pattern has 3/4 lambda. The next pattern has 5/4 lambda. So if I asked you to draw the fourth pattern, hopefully you would see, well, we went from 1 to 3 to 5. Hopefully you would see that the next pattern has 7/4 lambda in it. So that's the fourth pattern. And then the fifth pattern would have 9/4 lambda in it. So really, you can always get any pattern you want just by kind of starting at the first pattern and making your way by increasing the nodes and increasing the antinodes. So that's really all the information you need to understand sound waves in a tube. We're going to use this in our lab when I see you in class.